Chapter 3.4 Communication within the neuron. In general, messages are gathered by the dendrites and cell body and then transmitted along the axon in the form of a brief electrical pulse called an action potential. Each neuron has a stimulus threshold, a minimum level of stimulation from other neurons or sensory receptors to activate it. While waiting for sufficient stimulation to activate it, the neuron is polarized. That is, the axon's interior is more negatively charged than the fluid surrounding the axon. The resting potential or the negative electrical charge of the axon's interior is negative 70 millivolts. It has more sodium ions outside and more potassium ions inside. Sufficiently stimulated by other neurons or sensory receptors, the neuron reaches its stimulus threshold. The axon depolarizes, beginning the action potential. The action potential consists of sodium and ions and potassium ions closing and opening in channels, the result of a brief positive electrical impulse that progressively occurs at each segment down the axon is the action potential. The all or none law is the principle that either a neuron is sufficiently stimulated and an action potential occurs, or a neuron is not sufficiently stimulated and an action potential does not occur. Following the action potential, a refractory period occurs, during which the neuron is unable to fire. During this thousandths of a second or less, the neuron repolarizes. That is, it reestablishes the resting potential conditions. Two factors affect the speed of the action potential. Axon diameter: thicker axons are faster. Myelin sheath: myelinated axons are faster.